In the previous video we carefully looked at this particular function here and considered the local minimum, maximum and saddle points of it. We actually worked out the coordinates of those 4 points. In this video we will go on and do some more examples. Now we're not given this function, but we can see that at point A we have a saddle point, at point B we have a local minimum. In this function here we have a local max at A, a saddle point at B. Let's look at this function here. We want to verify that xy equals 0, 2 is a stationary point of this function. So these are just the x and y values of the stationary point. Well, we know from the previous video that we need to take the partial derivatives, and at a stationary point both partial derivatives must be 0. Well, that's clear for x equals 0. F sub x is going to be 0. What about f sub y? Well, y is 2, so we get 12 2 is 24 minus 6 times 4, so it's 24 minus 24. That's also going to be 0. So both partial derivatives are 0 for x equals 0 and y equals 2. So we have a stationary point at 0, 2. If we want to get the z value or f value of the stationary point, we just plug 0, 2 into this function, of course, as we saw in the previous video. Now we want to get a second stationary point of this function. This is the same function as before. So to get stationary points, as we saw in the previous video, you put both partial derivatives equal to 0. So if you set f sub x equal to 0, you only get one solution, x equals 0. However, if you put f sub y equal to 0, you get 12y minus 6y squared equals 0. If you solve that equation, well, that's a quadratic. You can factorize it into 6y times 2 minus y. So the product of these factors gives 0. So you put each factor equal to 0. So 6y equals 0 leading to y equals 0. 2 minus y equals 0 leading to y equals 2. Well, we already had y equals 2 as a solution. So this new solution now is y equals 0. So we put that solution with the solution for f sub x equals 0 because the point has to satisfy both equations simultaneously. So we put y equals 0 with x equals 0 and we get the point 0, 0. So that satisfies both of these equations. So this is a second stationary point of the function. So the two stationary points are 0, 0 and 0, 2. And we could go and get the z value of that by plugging 0, 0 into the function. You'll see that you'll actually get 5 if you do that. Let's take this example. F of x comma y is x to the 4 plus y to the 4 minus 36xy. We get the partial derivatives, so we differentiate this with respect to x. X to the 4 becomes 4x cubed, y to the 4 disappears, y is treated as a constant. Y is treated as a constant here, so we have minus 36y times x. So differentiating with respect to x, we just get minus 36y. We can factorize 4 out of that. Let's take df dy. Well, x is treated as a constant, so x to the 4 goes to 0. This term goes to 4y cubed. If x is treated as a constant, we just get what's in front of x, which is minus 36y. Sorry, I should say that